Hi there. Welcome to this lesson on Pure Mathematics 1. We're on Chapter 3, and in this lesson, we're looking at graphical solutions of simultaneous equations. Now, on a graph, if you solve a pair of simultaneous equations algebraically, on the graph, those solutions relate to the points which are on both lines or on both curves. They'll be the coordinates of where the lines cross each other, where they meet. It is possible in A-level maths that you'll be asked to draw scales on the axes and plot points accurately, but it is highly unlikely. It is much more likely that you'll be asked to make a sketch and then use your sketch and algebra to find where the lines cross each other. We'll show what all of that means through an example. So this first example, we're asked to draw a sketch of the following pair of simultaneous equations and then to use algebra to find where these two lines cross each other. I'll let you have a go at this yourself first, pause the video, and then come back to me when you're ready. Okay, let's have a look at this. So we need to sketch those two lines. The first one, y equals 2x minus 8. To sketch a line, you just need to know 2 points on it. The two easiest points are the crossing points on the axes. So first of all, we'll say what happens if x equals 0. If x is 0, then y equals minus 8, and that gives us the crossing point on the y-axis, here at minus 8. Then we'll say what happens if y equals 0. If y equals 0, then 0 will equal 2x minus 8, which means 2x equals 8, and x equals 4. That gives us the crossing point on the x-axis. Then we can draw the line and label it. Looking at the second equation, 2y equals 5 minus 3x, again, we say what happens if x is 0. If x is 0, 2y equals 5, which means y is equal to 5 over 2. That gives us the crossing point on the y-axis. If y is 0, then 0 will equal 5 minus 3x. 3x will equal 5, so x will equal 5 divided by 3, which is the crossing point on the x-axis. So we can then draw the line 2y equals 5 minus 3x. Now, what we're asked to find is the crossing point of these two lines, which is this point here. Doing that algebraically means solving the two equations simultaneously. Various ways you could do that, but what I'll choose to do is substitute the value of y from the first equation into the second one. So I'll get 2 times by 2x minus 8 is equal to 5 minus 3x. Multiplying out the brackets will give me that. Tidying that up will give me 7x is 21, which means x is equal to 3. Now, if x is 3, we just substitute that back into the first equation here, and we can find out y. Y will equal 2 3s is 6. 6 take away 8 is minus 2. And that will be the coordinates of the crossing point of the two lines, 3 minus 2, which is what we were asked to find. Second example is slightly harder. The first equation is still a straight line, but the second equation now is a quadratic curve. But again, have a go yourself, try and sketch both of those, and then use algebra to find where the line crosses the quadratic curve. Pause the video, come back to me when you're ready. Okay, let's have a look at these. We'll do the straight line first of all, y equals x plus 2. And again, if x equals 0, that means y will equal 2, which gives us the crossing point on the y-axis. If y equals 0, then that means x plus 2 equals 0, which means x equals minus 2, which gives us the crossing point on the x-axis. Then we can draw the line, y equals x plus 2. The quadratic, slightly trickier. Again, the crossing point on the y-axis is fairly simple. You just say what happens if x is 0. Well, if x is 0, then y will equal minus 8, and that gives us the crossing point on the y-axis. It's going to cut through the x-axis at 2 points. To find out where it does so, we need to solve when y equals 0. This quadratic does factorize into x minus 4 times x plus 2, and we need to know when that is equal to 0. Well, it equals 0 if x is equal to 4 in the first bracket, or if x is equal to minus 2 in the second bracket. So those will be the two crossing points of the curve on the x-axis. It's a right way up quadratic. We know what it looks like. So now we can sketch it. It'll be something like that. We've been asked to find the intersection points, so where the line crosses the curve. Well, that will be these 2 points here. And to find those, we're going to solve these equations simultaneously. And a bit like the first question, what I'll do is I'll substitute the value of y from the first equation into the second one. So instead of writing y here, I'll just write x plus 2 is equal to x squared minus 2x minus 8. I can rearrange that and I get another quadratic, a different one. X squared minus 3x minus 10 equals 0. Solving that, it does factorize into x plus 2 times x minus 5 equals 0. And that will give me two solutions. X equals minus 2, which is the point here that we knew was minus 2 already actually, and plus 5. And that looks about right from how the graph has been drawn. If x is minus 2, then we put minus 2 in here to find y. Minus 2 plus 2 is 0. And again, we knew that. Y equals 0 because it's on the x-axis, that point. The other point is when x is equal to 5. If x is 5, we'll have 5 plus 2, which is 7. And that gives us the coordinates of both of those points. So the crossing points are minus 2, 0 here on the left-hand side and 5, 7 here on the right-hand side. And that's the question done. Now, the last thing we need to do is just consider how the determinant of a quadratic impacts what it looks like when you have a line and a quadratic as a pair of simultaneous equations. Just thinking about the last example, that was what we solved. The first equation was a line, the second equation was a quadratic. When we solved those equations, we created a new quadratic, x squared minus 3x minus 10 equals 0. And we need to consider the determinant of that new quadratic that we created. The determinant is b squared minus 4ac, which will be 9 plus 40, which gives us 49. The only thing which is significant about that number is that it's positive. It's greater than 0. And if 49 is greater than 0, what that would mean about this quadratic, quadratic C, is that it would have two distinct roots. But what does that tell us about our original question, which involved a line and a different quadratic? Well, if the quadratic of the equation we created has two distinct roots, what it tells us is that the line and the curve, the original curve, they will meet at two distinct points. And you will get something like we had, the line and the curve meeting together at 2 points. What happens if the discriminant is equal to 0? Well, for a normal quadratic, if b squared minus 4 equals 0, that means the quadratic has got repeated roots, and the curve would touch the x-axis just at 1 point. What it means for us is that the line will touch the quadratic at 1 point, and you'll have something that looks like that. So if the quadratic that we create has a discriminant equal to 0, the original quadratic will just touch the line at one single point, like that. What about if the discriminant of our quadratic is less than 0, if it's negative? Well, if it's negative, that would mean normally that a quadratic has got no roots. For us, with simultaneous equations, with a line and a quadratic, it means that the line does not touch the quadratic. And when you draw the curve, you get something like that. There'll be the curve, there'll be the line, but they will never meet each other. Okay, one example for you to have a go at to do with this sort of thing. So example 3, the line with equation y equals 2x plus 1 meets the curve with equation kx squared plus 2y plus k minus 2 equals 0 at exactly 1 point. Given that k is a positive constant, find the value of k. Now, I will let you have a go at this. The significant thing in the question is where it says the line meets the curve at exactly 1 point. We're going to have to create a new quadratic by substituting y into the quadratic equation. Once we've created a new quadratic, we're then going to have to find the discriminant, b squared minus 4ac. We're then going to have to say that the discriminant has to equal 0, so that the curve and the line meet at one point. And then we should be able to work out what k is. I'll let you have a go at this yourself first. Pause the video, and then come back to me when you're ready. Okay, quite a lot going on in this question, but let's have a go at it. So the first thing we're going to do is substitute the value of y from the straight line into the quadratic. Y equals 2x plus 1. So instead of writing y here, we'll write 2x plus 1. Then we need to tidy things up. Multiplying out the brackets and collecting together terms gives us this. Kx squared plus 4x plus k is equal to 0. Now, for our original line to meet our original curve at one point, the discriminant of this quadratic has to equal 0. So we need to find the discriminant of this, b squared minus 4ac. And that has to equal 0. B squared is 16, minus 4ac is minus 4 times k, which is minus 4k squared. And that has to equal 0. Solving that, well, we get k squared equals 4, which means that k has to equal plus or minus 2. The question tells us that k is a positive constant. That means it can't be the negative value. So at that point, you'd say, because we're told that k is a positive constant, the answer must be k is equal to plus 2. That's the question done. Didn't have to do any sketching on that one. Okay, that is the end of the lesson. If you have the textbook, then turn to page 43 and have a go at exercise 3C. Thank you very much for listening, and cheerio.